Hello everyone, welcome to our session to chemistry YouTube channel. I am Agresh Shagan, here to teach you the chemistry till the foundation. So we are going to start the organic chemistry of class 12th. Its first chapter is haloalkanes and haloarenes. This is the first lecture of that chapter. So here are the contents which we are going to study about this chapter. The first is introduction, what are haloalkanes and haloarenes, and the second one is classification of haloalkanes, how the haloalkanes are classified, what are their methods and techniques, and then the structure of haloalkanes, what is the structure of haloalkanes. Then the other thing is nomenclature of haloalkane, and the last is method of preparation of haloalkane. So here is the introduction to haloalkanes. Firstly, haloalkanes are the halogen derivative of the hydrocarbon. Like hydrocarbon, what is hydrocarbon? So hydrocarbon is basically the mixture of hydrogen and carbon only. Means those compounds which are only formed by the mixture of hydrogen and carbon. Like example, CH4, C2H6, C2H4, C3H8, C3H4, C3H6. So these are the compounds which are made of carbon and hydrogen only. Now, if we have a single compound like single haloalkane, then this haloalkane should react with halogen and sorry, this hydrocarbon should react with halogen and then react and then loses its hydrogen, so it make CH3X. The compound which is formed is haloalkane. The compound which is formed is haloalkane. Same for the haloarenes. Haloarenes are the halogen derivative of aromatic hydrocarbon. Simply we say that if aromatic hydrocarbon, what is aromatic hydrocarbon? Aromatic is the word which is derived from the Greek word named as aroma, and that aroma means smell. Okay. Okay, so that aroma means smell. So those compounds which have 4n plus 2 pi electrons according to Hakel rule, according to Hakel rule, those compounds are known as aromatic hydrocarbon. Those compounds are known as aromatic hydrocarbon. Okay, so here is the reaction of the hydrocarbons. Like this is the CH4, it reacts with Cl2. So this is CH4 molecule and this reacts with Cl2. Now here the H and Cl removes by reacting with themselves, so it make HCl, and the final product is when the hydrogen loses its site from the CH4 and the chlorine loses its site from its molecule, then these two sites combine together and form the compound named as CH3Cl, means chloromethane. Same for the next, then the CH3Cl is react with again Cl2, and that the one hydrogen from CH3Cl is going with a chlorine molecule again, and it forms HCl and forms CH2Cl2. Then again there is a one hydrogen and one chlorine react with each other and form HCl and gives CH3Cl, which is known as trichloromethane or chloroform or chloroform. Okay, then this chloroform has also one hydrogen atom. Then this hydrogen atom also leaves the site of carbon with chlorine molecule and form HCl, and this forms CCl4 named as tetrachloromethane, means pyrene. Okay, then the classification of haloalkanes, basically these are different types of haloalkanes. So the first one is monohalogen. Monohalogen have three types: primary alkyl halide, secondary alkyl halide, and tertiary alkyl halide. Polyhalogen derivatives have three types: dihalogen derivatives, trihalogen derivatives, and tetrahalogen derivatives. Dihalogen have Gemical and vicinal dihalides. So here, what are PST haloalkanes? PST, P means primary, S means secondary, T means tertiary. Okay, the primary, secondary, and tertiary haloalkanes, we are going to study about these haloalkanes. So in easy language, if we want to study about PST haloalkanes, the primary haloalkane is then the primary haloalkane is also known as 1 degree haloalkane. Okay, 1 degree haloalkane means when the halogen atom is connected to carbon, then that carbon should be connected by one carbon only. If this is the first carbon which is connected to the group, this is the second carbon. Okay, if the first carbon which is connected with the group is connected to only one carbon, then this must be 1 degree haloalkane. For 2 degree haloalkane, here X atom is connected to the first carbon, and that first carbon must be connected to other two carbon atoms. Then this is 2 degree haloalkane. And there is tertiary haloalkane, means 3 degree haloalkane. So if the X atom, which is halogen atom, this is connected to the first carbon, and that first carbon must be connected with three different carbon atoms, then that is tertiary haloalkanes. What are Gemical and vicinal dihalides? Gemical, carbon. When a single carbon atom is connected to two halogen atoms, is connected to two halogen atoms, then that compound is known as Gemical haloalkane, means Gemical dihalide. This must be known as Gemical dihalide. In easy language, we say that when two halogen atom is connected to only one carbon, then this is known as Gemical dihalide. And then about vicinal, when two halogen atoms two halogen atoms are connected with two adjacent two adjacent carbon atoms, then this is vicinal dihalide. Then this is vicinal dihalide. Okay, tri and tetra haloalkanes. Tri means 3, tetra means 4. When any hydrocarbon have 3 halogen atoms in it, like CH4 is a hydrocarbon, it gives after it gives CHCl3 after reaction with Cl2, then this methane hydrocarbon has 3 chlorine atom with it. That's why it is trihaloalkane. Trihaloalkane. In easy word, we say that if an if there is if there is three halogen atom present in carbon chain, then then this should be known as trihaloalkane. For 4, like CCl4, here the methane loses all its hydrogen atom and connected their bonds with chlorine atom and satisfied their bond with chlorine atoms like this. Okay, then this is the hydrocarbon which have 4 different or 4 same halogen atoms. When any hydrocarbon have 4 same or 4 different halogen atom, then that haloalkane should be known as tetrahaloalkane. tetra haloalkane. Okay, now the structure of haloalkanes. Here we go. This is carbon atom. This is carbon atom. Now this is connected with hydrogen atom. Now this is connected with hydrogen atom, and this carbon atom is connected with another X atom, another X atom. Okay, this X atom is known as halogens. This X atom is known as halogens. Basically, what is the perfect structure of haloalkanes? This is the main question of that of the students. Okay, so now there is a only easy simple trick to remember the hybridization, the geometry, and the bond angle. Okay, so for this we have to go for a technique like whenever there is a single bond. Remember, single bond contains one sigma bond, double bonds contain one sigma and one pi bond, triple bond contains one sigma and two pi bonds, a lone pair contain one sigma bond and coordinate bond contain one sigma bond. Okay, so basically all these bonds, lone pairs and coordinate bond contains one sigma bond. So if there is only one bond, it is very easy to clarify that how many sigma bonds are there. So the first thing is we should count the sigma bond, how many sigma bonds are there. So go for it. There is one sigma bond, the second sigma bond, the third sigma bond, and the fourth sigma bond. Total number of sigma bond is 4. Go for hybridization priority S P P D D D. And this is the basic technique. Count the number 1, 2, 3, and 4. So this is 1, this is 2, this is 3, this is 4. Okay. So your perfect hybridization is 1 orbital of s and 3 orbital of p are involving in the hybridization. So your hybridization is sp3. Now if the hybridization is sp3, if the hybridization of this carbon is sp3, it gives the geometry of tetrahedral. It gives the tetrahedral shape geometry. Okay. Now this tetrahedral shape of geometry has bond angle 109 degree 28 minute. Has bond angle 109 degree 28 minute. Okay. So mostly all the haloalkane compounds which are directly connected to the single bonded carbon chain, are of sp3 hybridization and shows tetrahedral geometry and forms a bond angle of 109 degree 28 minute. Okay, this is the basic structure. Like this is the center carbon, this is the basic geometry of tetrahedral. This is the shape. Like this is carbon atom, and the carbon atom is connected with 4 different bonds. Maybe halogen, may not be halogen. Okay, so this gives this type of geometry. फिर nomenclature of haloalkanes are done with the two names, common name and IUPAC. For common name we should follow the pattern of alkyl halide, For example, here is CH3Cl. So this CH3 means methyl, and this chlorine gets converted with halide. Like chlorine, we remove I and E from chlorine and add IDE Okay, this IDE will gives chloride. This is the halide form of any halogen atom. Like chlorine, there is fluorine which gives fluoride, there is iodine which gives iodide, and there is bromine which gives bromide. Okay. In IUPAC, we should write the name of these compounds as like haloalkane, as like haloalkane. Okay, clear? So this CH3Cl will be written as, the chlorine is written as chloride in common name, and in IUPAC we should write chlorine as chloro. The methyl is written as, the CH3 is written as methyl in common name, and in IUPAC we should write it as methane. So the name in IUPAC will gives CH3Cl of name in IUPAC is chloromethane. Same for CH3CH2Br. There are two carbon atoms and one bromine atom. So it gives common name of ethyl bromide and IUPAC name of bromoethane. Same for CH3CH2CH2I. There are three carbon atoms and one iodine atom. It gives N-propyl iodide and one iodo-propane. We should write one or not write one. This is the question of many students. So if any functional group is connected to the first carbon of the carbon chain, then it's your uh, it's your choice. Either you wish to write the number of the carbon number or not. You should directly write it as iodopropane. It must be countable as the iodine is connected to the first carbon atom. Okay. Same for these compounds, other compounds like uh, we have we have this type of compound. This gives, this is the very basic compound, and the structure is known as bond line structure. The structure which is drawn here is known as bond line structure. It shows that, bond line structure shows that every corner of the given compound contains carbon. So here are only five corners. So the parent chain is of 5 carbon, and the chlorine is connected to the first carbon atom. So its name should be written as 1 chloro, 5 carbon is named as pent, and there are carbon carbon single bond named as alkane. So the name of this compound is 1 chloropentane. Like there is CH3, CH3, sorry, and there is CH3, 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 and this is Cl. So this carbon and the group. So now look at here, that the chlorine group is connected with first carbon atom, and that first carbon is connected with three other alkyl groups. Connected with three other alkyl groups. This alkyl group are the basic function for the classification of PST haloalkanes. So if the first carbon is connected with three other alkyl groups, then it must be known as 3-degree haloalkane. 3-degree haloalkane name is written as tert. 3-degree haloalkane name is written as tert. There are total number of carbon atoms 1, 2, 3 and 4. Butyl chloride. Tert butyl chloride. Okay, understand?